Hello everyone. In this session we'll see another question on complex functions. So we'll check for the continuity in this question, and it says check the continuity of the function at z equal to 0 if f of z is equal to 0 at z equal to 0 and is equal to imaginary part of z square divided by absolute value square of z if z is not equal to 0, right? So basically there's a function f of z which is 0 at z equal to 0, and for z not equal to 0 it is given by this imaginary of z square divided by mod of z square. So we have seen many times that z square is, we have already seen, and you can also expand it for, let's say if z is x plus iy, then z square will be given as x plus iy square or x plus iy into x plus iy. In this case we will have x square minus y square as the real part plus I times of 2xy, and this is the imaginary part of z square. So imaginary z square is 2xy. Fine. We also know that z square mod value is simply x square plus y square. So this f of z is 2xy by x square plus y square for the case of z not equal to 0. For z equal to 0 it is 0. So if we are checking the function's continuity at z equal to 0, what we need is the limit of f of z tends to z naught should be equal to f of z naught, and in this case z naught is actually 0 or origin. So basically we have to find the limit of the function at z tends to z naught and have to check whether it is equal to the function value at z naught, right? And what is this z naught? Z naught is at origin, and this is the function. So f of z for z tends to 0, that is x tends to 0, y tends to 0 for 2xy by x square plus y square. So if we are approaching this z naught, let's see in the xy plane, this is that point. We may be approaching from like this x-axis, maybe from the y-axis, maybe from here, or any direction. We must be approaching this z naught, right? Coming closer to this. That means, and it can be straight line, it can be curve, anything. So why not to try? Let's see if we are approaching from a straight line, y is equal to mx, if we are having this limit constant. So for approach from a straight line, this is going to be 2x into mx by x square plus m square x square. So definitely we can cancel out this x square from numerator and denominator. We will be left with 2m by 1 plus m square, right? And of course we are approaching z to 0, but we can clearly see that there is no variable x and y here. It only depends on m. So this depends on m, which means if we are approaching from for different slope, we will have the function value or the limit to be different, right? Like what if we are approaching from y equal to x, the value will be different because m will be equal to 1. What if we are approaching from y is equal to 2x, the value will be m equal to 2, so the function value will be something different, which means that the limit does not exist, right? So we can say limit at z tends to 0 does not exist for f of z. So we have seen that for the function to be continuous, the function should be defined at that point, the function limit should also be defined at that point, and the function limit and the function value should be same. But now that the function limit is not existing, we can clearly say f of z is not continuous that's it.